Hello everyone and welcome to the 14th electronics tutorial. In this tutorial we will look at the transformer. A transformer is used to reduce or increase the voltage of an alternating current. You will find transformers in most all of your home appliances. For example, your TV or computer will take the power from the wall socket. The high voltage supply will be stepped down to a lower voltage to power all the other sub-circuits at the correct voltage level. A typical transformer consists of an iron core with two sets of copper wire coiled around opposite edges. The side where the input signal is placed is called the primary winding, and the side where the output signal is produced is called the secondary winding. The ratio between the primary and secondary windings determines whether the transformer will step up or step down the original signal. The alternating current on the primary coil creates a changing magnetic field in the iron core. This will induce a current in the secondary coil. The schematic symbol in every circuit represents all the parts of the transformer. The two lines in the centre represent the iron core. To the left of this is the primary coil, and to the right is the secondary coil. The numbers in the centre above the core represent the number of primary and secondary turns. One application for the transformer is to create a circuit which will convert a high voltage AC signal to a lower voltage DC signal. Firstly, we need to look at the formula to calculate the primary and secondary turns on the transformer so we can achieve the correct output. The formula is as follows. Voltage out equals secondary turns divided by primary turns multiplied by the voltage in. When we go over to the simulator, we want to demonstrate how we can use the transformer to power an LED using a mains voltage supply. To do this, we must firstly make sure our ratio is correct to step down from 339 volts AC to 5 volts DC. So we will set the primary turns to 60 and the secondary turns to 1. Our input voltage is 339 volts. 1 divided by 60 equals 0.0166667. 0.0166667 multiplied by 339 equals 5.65 volts. 5.65 volts at the output is adequate for our application, so let's now go to the simulator and explore the working model. So here we have the transformer placed in a circuit. We have the 339 volts sine wave at the primary side of the transformer. We also have a diode, two capacitors, and an LED with a current limiting resistor placed on the secondary side. The windings ratio is set to 60 to 1. Notice that switches have been placed before some of the components. This is so we can see the effect each component has on the output signal. Firstly, let's look at the signal on the primary side of the transformer. As we can see, it is a 339 volts sine wave. Let's look at the secondary side. The transformer has stepped down the voltage of the signal. We have a 5.64 volt peak sine wave. This is the voltage we require, but we need to smooth out the sine wave so it is closer to a steady DC voltage. Let's add the diode into the circuit to restrict the flow of negative voltage. To see the effect of the diode, we need to view the signal after that point. The signal is now at maximum 4.82 volts and minimum negative 2.81 volts. Notice also the sine wave is slightly distorted and the LED is flashing on and off. So the diode has reduced the voltage by 0.82 volts, but is not smoothing the signal enough to keep the LED fully lit. Let's now add the first 1 millifarad capacitor. The capacitor has smoothed the signal further. It has changed from a sine wave to a sawtooth waveform. It has a maximum of 4.62 volts and minimum of 4.35. It is only 0.27 volts of a difference, so the signal is much smoother. Let's add the last capacitor to see the effect it has. The second capacitor has further smoothed out the signal. We now have a voltage at a maximum of 4.57 volts and minimum of 4.43 volts. There is now only a difference of 0.14 volts. We can improve the circuit further by adding more diodes to create a full wave rectifier. With this arrangement, and using the same values of capacitors, we can smooth the signal down so there is only a difference of 0.7 volts. This signal can be further smoothed out by using additional circuitry to create a voltage regulator. We will explore power supplies again in later videos to cover the topic in greater detail. I hope you have enjoyed this video. In the next video we will explore logic gates. Please feel free to ask questions and leave comments. All the best.